I've run a crazy amount of benchmarks, and I can tell you the 5090 is not 2 times faster than a 4090, like Nvidia claimed in their announcement, because they were relying on multi-frame generation. However, I am going to talk about multi-frame generation, and we will see side-by-side footage, and I do like the technology. It's just not quite raw performance, and so we do need to be careful about that. If you do limit it to apples-to-apples comparisons, I'm getting a 23% geo mean on my total benchmark suite. However, some of those, especially at lower resolutions and using upscaling aggressively, which I did test out here, you can introduce a little bit of CPU limitations. So if we stick to like 4K native results, I'm seeing more like a 26% performance uplift for the 5090 versus the 4090, but it's also 25% higher MSRP. So it's looking like we overall have the same performance per dollar, but more overall performance, at least if you're comparing MSRPs. It is true that 4090s haven't been really restocking anywhere near MSRP, which has driven up their price on the actual market. And like I said, I do think multi-frame generation is good. It's very usable. It's really interesting on a high refresh rate display. I'll even have a separate video really talking about that. But we do have a lot to go over. Overall plan here is we're going to go through a massive number of side-by-side benchmarks showing overall frame rates and a lot of detailed thoughts, and then come around for a summary of some results and how it stacks up against the 4090 overall. And if you are thinking that the 50 series is a time that you should be selling your old GPU before it gets devalued and help you fund your upgrade, I couldn't agree more. And you should check out Jawa.gg. This is the marketplace where gamers buy, sell, and upgrade. You're selling to each other. You can you can make your own listings. Or if you're looking for something super convenient, you can actually sell directly to Jawa to get an instant offer on CPUs and GPUs. But again, you can make your own little side business, creating your own listings and all of that. So whether you want to take all the hassle out of it or manage all the details, it's there. There's a bunch of pre-built systems, a ton of positive reviews, and overall, they also have an amazing Discord community where you can get that one-on-one feedback that a lot of people are super valuing. Also, I can save you $10 off your first purchase on Jawa. And honestly, if a lot of you are watching this video but you can't really afford a 5090, you can probably get some amazing value checking out used GPUs. I highly recommend it. And again, $10 off your first purchase using code ON10. Follow the link in the video description and or pinned comment. And a huge thank you to Jawa for sponsoring today's video. Now, let's jump into the side-by-sides, but let's not start here. Let's actually start here. So let's make it perfectly clear that even the 5090 at a native 4K resolution with no upscaling isn't going to be powering through a path-traced game at native 4K. That's what we're seeing tested out here on the 5090 versus 4090, and we're seeing actually the largest percentage difference for the 5090 out of all of my testing. It's a bit of an outlier at 42%. Most of my results were mid 30% at best, and a lot of them in the 20% advantage range. So I actually want to explain why I think this one came out as a bit of an outlier. We're talking about extremely small numbers, which means that if one of them gets rounded up and the other one gets rounded down, those 1 to 2 FPS changes can actually have a wild swing on the percentage difference when you calculate it. Let me show you on a calculator. So here we had 34 divided by 24, which came out to 42% faster. But that 34 was probably 33 point something and it rounded up, and that 24 was probably 24 point something and got rounded down. If it had been a 33 and a 25, that would have come out as 32% faster, which is much more in line with the rest of my testing. So I do just want to point that out. I also want to mention that if my averages come out maybe slightly different in a 5090 versus 4090 comparison than other outlets, remember that not everybody has the same models of GPUs. My 5090 is a Founders Edition review sample. My 4090 I bought myself, and I bought the only one I could because the stock was not amazingly available when I was buying them. And it's the Gigabyte Gaming OC. It maybe runs slightly faster. We'd be talking single-digit percentage differences compared to a Founders Edition 4090. But that could then slightly change the percentage differences again If you were looking at 5090 versus 4090 Founders Editions, just something to keep in mind if you're comparing my results to other review outlets. But again, we're talking extremely minor differences. So again, we're seeing the path tracing results at native 4K really isn't that relevant anyway, because this isn't the frame rates you will be playing on a 4090 or a 5090. You will change the graphics settings. So let's do that. Here, though, I want to emphasize what I was saying about frame generation is interesting, but it's not raw performance. What are we looking at here? First of all, this is not using upscaling. Frame generation and DLSS upscaling are not the same thing, and you don't need to run them at the same time. What I'm showing you here is the 5090 taking the results we just saw a minute ago of like 30-something FPS and running ×4 frame generation on it. So where now it's reporting 120 frames per second, but it's only actually rendering about 30 frames per second, which means it's only as responsive as about 30 frames per second, and it also means it's going to be fairly hard to generate frames accurately. So that's why I don't like Nvidia's claim about this being raw performance. Frame generation should be thought of as a win more feature, meaning it's not good at taking a losing situation and making it a winning situation. It's not good at taking 30 FPS to 120 FPS and having a good experience. But it is fantastic at taking an already winning situation like 60 FPS or so and making it now 240 frames per second on a high refresh rate display. It's amazing for that. But that's why it's important to distinguish it from raw performance. Because if your GPU is only going to get 30 frames per second at certain graphic settings, kicking on ×4 frame generation is still going to have a lot of latency, which you can see here. So there is latency measurements in my testing on all the games that supported it. So you can kind of keep an eye on things that way. But also image quality isn't amazing at these settings. That being said, I might actually prefer the motion fluidity of this turned on versus turned off at 30 FPS versus frame generation off of it. But just because I like it better than a raw 30 FPS does not mean I think it's a good experience. I absolutely think it only makes sense when coming from a higher base frame rate. Also, what I'm showing here is what Nvidia is talking about, which is using the max version of frame generation available to an RTX 4090, which is the ×2 mode, where there is one generated frame in between every 2 rendered frames. So in other words, it alternates generated and actually rendered frames. And the maximum supported frame generation mode on the 5090, which is ×4 mode, which inserts 3 generated frames between every 2 rendered frames, or in other words, 3 out of every 4 frames are generated rather than actually rendered by the game. Anyway, so I'm showing this result because that's what Nvidia is talking about when they say this, but I'm emphasizing that coming from a low base frame rate, it doesn't actually create a good experience. But if you come from a high enough base frame rate, you do get better results. And I didn't compare this non-apples to apples thing in my bar graphs. So what are we looking at here? First of all, let's turn frame generation back off and just try to increase the base amount of rendered frames. Using DLSS quality is able to get the RTX 5090 to 64 FPS in this built-in benchmark, and notice the latency number is down in the low 30s. For milliseconds. For a single-player game, it is extremely playable. Do keep in mind I do have NVIDIA's reflex latency reduction turned on in all of this testing where it was available. The 4090 is only able to get into 48 FPS average here, so the 5090 is 33% faster, and it does help you get a high enough base frame rate where then using frame generation might make sense. Also notice, what do I mean by transformer model? NVIDIA has updated the upscaling, not just the frame generation, to support a new transformer model, which I think looks great. Also, it does have backwards compatibility with the 2030 and 40 series. However, NVIDIA has warned that performance might not be as good on the older cards. I wanted to test if the 4090 is just as good on the transformer model as it is on the CNN model. The CNN model is the older version that you're used to with DLSS Super Resolution. This is a convolutional neural network that DLSS has used for the last several years. Now, we can see here that the overall results are not much different. The 4090 is averaging 1 FPS better in the built-in benchmark run on the older CNN model compared to the newer Transformer model. It doesn't really change the overall results. The 5090 is 31% faster here, and the overall experience is pretty similar. But this was basically just experimental because I wanted to find out if there was a major difference between running the CNN model and the Transformer model on a 4090. Do keep in mind that you might not want to assume that it's not going to matter much for other GPUs because the 4090 has a lot of tensor cores. Anyway, let's go ahead and switch to performance mode upscaling. Using the new Transformer model, I actually find the performance mode upscaling when outputting to a 4K resolution. That's important because it doesn't look as good at lower resolutions. But on a 4K display, I find the performance mode much more usable than it used to be, to where this actually was my preferred way to play when just testing out playing games on the 5090 in Cyberpunk specifically. Was using the performance mode with the Transformer model. That gets the base frame rate to 92 FPS on the 5090, and the 4090 is able to hit 72, which is very respectable. Once again, notice that increasing frame rates through upscaling does improve latency, where again, we're down in the upper 20s, low 30s in millisecond range. It varies as the scene changes, but pretty responsive for a single player game. Now, I also tested out the CNN model for performance mode upscaling, and again, not much of a difference at all between what we saw in the Transformer model, other than image quality being better on the Transformer model. Performance numbers are about the same, 92 versus 72, the 5090 showing 28% faster. So let's go ahead and jump forward to this. So this is using all available frame generation technologies. So the 4090 can use ×2 frame gen mode. Notice I'm back to the quality level upscaling. So this is where the 4090 was coming from less than 60 FPS baseline before using the ×2 frame gen. So its latency is still fairly high, often above 50 milliseconds, but sometimes in the 40s. Some people might find it playable. There's going to be very different experiences based on your personal preferences and tolerances. The 5090 at ×2 frame gen mode goes up to 114 FPS output. Will feel more like half of that, but that's a 31% advantage, and then it has a ×4 mode, which gives it the over 2 times faster thing. But again, it's not really an apples to apples comparison there. If we go into the performance mode upscaler as the baseline before kicking on frame gen, now the 4090 is offering a pretty good experience here. Because it's over 60 FPS before kicking on frame gen, giving it 125 FPS of motion fluidity while feeling about as responsive as 60 FPS. The 5090 outputs 159 FPS in the ×2 mode while feeling as responsive as about half of that. And then it could go up to a ×4 mode, which only adds a few more milliseconds of latency, but adds a lot more motion fluidity to the screen. Notice it's actually getting close to 300 FPS at times. It's hitting 280 average. So honestly, it's actually too much for my 240 Hz 4K display. If I use the performance mode upscaling plus frame gen on the 5090 on a 240 Hz 4K display, I actually use the ×3 frame gen mode, which is also available to make sure I stay under my monitor's maximum refresh rate to help with the motion fluidity on the screen. Anyway, but what about 1440p? Some people are chasing super high refresh rate 1440p rather than 4K displays, even if you're buying something like a 5090. Totally makes sense. If you're doing that, the 5090 can deliver over 60 FPS in path-traced Cyberpunk at a native 1440p resolution, not relying on any upscaling or frame generation, and no GPU before this could do that. The 4090 was averaging 49, giving the 5090 a 31% performance advantage at these settings. Now, that being said, you could actually kick on frame generation without upscaling. If you want that native 1440p image quality without using any upscaling, you still might then use frame generation to boost the motion fluidity from there. Again, they're decoupled. You don't have to upscale when using frame generation. In ×2 mode, the 4090 is hitting 91 and the 5090 is hitting 117. Remember, the responsiveness will feel like about half of that. And that's a 29% advantage for the 5090 in an apples-to-apples comparison, whereas the ×4 mode can go all the way up to 220 FPS of motion fluidity, but the responsiveness will feel like about 1/4 of that, which still feels pretty good, because 1/4 of that is still a reasonable responsiveness for a single-player title. So it's actually a decent way to play the game. At 1440p RT Overdrive mode, but using DLSS quality upscaling, no frame generation, using the transformer model, we see the 5090 only 23% faster now, at 108 FPS versus 88 on the 4090. And again, these are all real frames, although they are upscaled, meaning this feels very responsive here. You can see latency down in the low 20 millisecond range for the 5090. Anyway, if we go ahead, but why is it only 23% faster? The GPU is not fully utilized on the 5090 right here in this more city environment with more NPCs, meaning even a 9800X3D is slightly holding back the 5090 on this result. So keep that in mind. If we move on to RT Overdrive DLSS quality again, but this time using the CNN model, the older version of DLSS upscaling rather than the transformer mode, the results are fairly similar. We're now at 113 and 90, 26% advantage for the 5090. Again, you will see times where it drops below 99% utilization, indicating slight CPU limitation at times, even on the fastest gaming CPU on the planet. It's just pretty high frame rates for a complex scene with path tracing. Anyway, let's go ahead and jump on to frame generation. So if we use frame generation on the DLSS quality upscaling using the transformer model, since it looked better and performed about the same on both GPUs, the 5090 is able to hit 186 FPS of motion fluidity while feeling as responsive as about half of that, which is very good. And the 4090 hits about 152 while feeling responsive as about half of that, which is very good. And in the ×4 mode, the 5090 can hit 337 FPS. So if you got a 360 Hz 1440p display, which some people on high-end systems do have, this could take full advantage of the motion fluidity on offer while still feeling quite responsive, just about as responsive as 1/4 of that number. Let's go ahead and look at 1080p native RT Overdrive just for the heck of it. There's not going to be a lot of 1080p testing in this video because the 5090 is usually going to be CPU bottlenecked and go a bit wasted at 1080p. That being said, with RT Overdrive, the GPU is still doing quite a bit, so while we can see it be slightly CPU limited at times, it's still 25% faster than the 4090 and hitting 99 FPS here, and the 4090 is hitting 79. Again, no upscaling or frame generation involved here. That's enough Cyberpunk. But let's do some more ray tracing testing. Let's do something that's not path tracing. How about Indiana Jones and the Great Circle at 4K Supreme? That's the maximum settings, and this game always includes ray tracing, but maximum without going into the full RT path tracing mode. This shows the 5090 20% faster at 126 versus 105. And it's overall a great experience on both GPUs. If we kick on DLSS quality, by the way, the rest of the games I'm testing here haven't been updated to include the transformer model and for upscaling, so it's using the older CNN model in the rest of the video, and I did not use the Nvidia app to use the override feature to try switching it. We're just doing the games as they are currently available. Anyway, 5090 is now 17% faster using DLSS quality upscaling, 162 FPS versus 139. It looks great, it plays great on both GPUs. But if we try to enable the full RT mode on top of the supreme graphics settings, we are seeing the 5090 take a 31% lead at 38 FPS versus 29, meaning it's actually not a great experience on either GPU. Also, in this game, my latency monitor did not appear to be working. So it reports 0 milliseconds of latency. That just means it's not working. Anyway, if we kick on DLSS quality upscaling, the 5090 is now able to break 60 FPS average at 62 versus 49, 27% lead, and that's a pretty decent baseline for enabling some frame generation. This game has the normal ×2 mode available, and you can override settings like that in the Nvidia app if you wanted to access the additional multiples. The 5090, at DLSS performance mode, the 5090 is now able to hit 82 FPS versus 65 on the 4090. So now we're reaching very playable performance on both GPUs. And again, could use this as a baseline for frame generation, but I'm not going to test frame generation for the rest of the video because I already did a ton of that in Cyberpunk. Anyway, if we go to 1440p native, no upscaling, we're at Supreme plus the full RT mode. The 5090 is able to average over 60 FPS in this demanding jungle scene, 25% faster than the 4090, which is hitting 51. If we kick on DLSS quality, the 5090 jumps to 94 FPS and the 4090 jumps to 75, giving the 5090 a 25% advantage. And at Supreme settings, native 1440p with no full ray tracing. This does still include ray tracing, but not the full RT mode. The 5090 is only 12% faster, but again, we're showing signs that the GPU might be being a little bit held back by the rest of the system here, not always at 99% utilization, and our frame rates are crazy high, 174 versus 155. Let's move on to an Unreal Engine 5 showcase. This is one of the best looking ones currently out, although not necessarily the best optimized. Silent Hill 2 at 4K native, no upscaling, epic settings with the hardware accelerated ray tracing turned on. We're seeing 66 FPS on the 5090 versus 52 on the 4090. So we finally have a GPU that can average over 60 FPS in this game. At completely maxed out with no upscaling. It's a 27% lead. If we do kick on DLSS quality, which still looks great and probably be how I'd play it, the 5090 is now hitting 91 FPS, which is 23% faster than the 4090, which is hitting 74. With DLSS performance mode upscaling, the 5090 cracks 114 FPS, making it 21% faster than the 4090 at 94. And the 1% lows are starting to get a bit compressed by Unreal Engine 5 just being a stuttery mess, and it's not related to how fast the GPU is. At Silent Hill 2 at 4K native, no upscaling, epic settings, but no hardware accelerated ray tracing, so just the software Lumen. We're seeing 73 FPS on the 5090 versus 61 on the 4090, giving a 20% advantage to the new 90 class. If you kick on DLSS quality, both do great, 113 FPS versus 91, 24% advantage to the 5090. And at 1440p native epic settings with ray tracing turned back on, it's 100 FPS versus 83, 20% advantage to the 5090, but they're both doing great. With DLSS quality on the 1440p epic with ray tracing settings, we're getting 127 FPS versus 108, only 18% advantage for the 5090. But again, I think we're starting to get into other limitations at times and Unreal Engine 5 being frustrating. Anyway, 1440p native epic settings, no upscaling, but no hardware accelerated ray tracing. We get 122 FPS versus 101, which is a 21% advantage to the 5090. In another Unreal Engine 5 showcase, but not one that features hardware accelerated ray tracing, we have Hellblade 2 Senua's Saga at 4K high settings, which is the highest available in this game. There's nothing above it. The 5090 is 23% faster at 76 versus 62. If we go to DLSS quality on the maximum settings, it's 111 versus 96, which is a 16% advantage. And if we go to 1440p max settings, it's a 19% advantage at 115 versus 97. So both GPUs give you a pretty great experience in this game. Let's move on to Final Fantasy XVI, which is one of the most demanding games out there at 4K native ultra. We're doing 78 versus 66, so both do a adequate job here without upscaling. 18% advantage to the 5090. If we do kick on DLSS quality, we're now into higher refresh rate experience territory at 108 versus 93, and a 16% advantage to the 5090. And if we use DLSS performance mode, we can go up to 135 versus 117, which is a 15% advantage to the 5090. Again, note that the GPUs are not necessarily fully utilized at all times in this NPC-populated environment. Again, so it's potentially possible that once a faster gaming CPU than the 9800X3D exists, we might see a bit more scaling here. At 1440p ultra settings, we're 117 versus 103, which is a 14% advantage for the 5090. In God of War Ragnarok at 4K Ultra, you don't need any upscaling here. We're going 128 versus 98. They're both doing a great job, 31% advantage to the 5090. But if you have a super high refresh rate 4K display, kick on DLSS quality and you're at 170 versus 136, 25% advantage to the 5090. At 1440p Ultra, we're at 183 versus 149, 23% advantage to the 5090. In Horizon Forbidden West at 4K very high settings, which is the maximum settings this game offers, we're at 121 versus 95, 27% advantage to the 5090. If you kick on DLSS quality, it scales all the way up to 155 versus 128, 21% advantage to the 5090. And at 1440p max settings, we are getting 175 versus 150, 17% advantage to the 5090. At Ghost of Tsushima, at its maximum settings, which are called very high, 4K native resolution, we're at 119 versus 92, which is a 29% advantage to the 5090. If we kick on DLSS quality, we scale all the way up to 170 FPS on the 5090 versus 136 on the 4090, 25% lead for the 5090. And at 1440p native, very high settings, we are at 179 versus 149, which is a 20% lead for the 5090. Keep in mind that it's not always at 99% GPU utilization. So we're actually a bit CPU limited now, even on the fastest gaming CPU on the planet. So again, once faster gaming CPUs exist, you'll see a bit more scaling here for the 5090. Call of Duty Black Ops 6, I decided to test at basic settings, which does mean we tend to be a little bit more CPU bound, but is maybe more realistic to the settings you would use on a competitive online game. We're seeing a 15% advantage at native 4K, but basic settings at 204 versus 178. If you can't get the kill at these frame rates, it's probably a skill issue. At 1440p basic settings, though, you can scale up to 301 FPS on the 5090, but it's being held back by our 9800X3D here, so the 4090 is able to stay within 8% of the performance at 278. And at 1080p, we're basically CPU bound at this point, and we're just showing the limits of the 9800X3D at 341 versus 327, so only seeing 4% scaling for the 5090 here. All right, let's go ahead and jump into some giant bar graphs for some final thoughts. So, what do I think overall of the 5090? Again, it's around 25% faster for around 25% more money when comparing MSRPs, so that makes it not incredibly exciting. It's also incredibly fast. So like, if you're wondering, is the 5090 a good graphics card? Would I regret buying it? I mean, if the money doesn't matter to you, if $2,000 for your favorite hobby is like depending on your income, that could be something you could just easily afford. And it doesn't, you know, you're not going into debt to afford it and you're not skipping meals. Then yeah, you're gonna have an absolutely amazing graphics card if you buy a 5090. Now, if you're watching this video because you already have a 4090 and you're wondering if you should upgrade to a 5090, then I don't think that's really worth it. I would skip a generation. Your raw performance isn't enough better to really matter. Again, if money is just meaningless to you and you already have a 4090, I would say the biggest selling point probably is if you already have a 4K 240Hz display, then having the additional multi-frame gen feature can help smooth things out on an extremely high refresh rate display. I don't think that feature's worth, you know, a massive amount of additional money or anything like that, but it is nice to have on a super high refresh rate display. Let's break into the summary here a bit. So the only frame generated figures being compared in these bar graphs are when it's ×2 versus ×2. So I'm not including ×4 versus ×2 the way Nvidia does, because I think that's implying things that it's not combining like terms, it's combining unlike terms, because the frame rates don't mean the same thing if a different percentage of them are generated versus not. Whereas ×2 versus ×2 is still an apples to apples comparison. Anyway, so in all of my results, which we noticed were somewhat CPU limited, especially at 1440p and 1080p results, and even on the more aggressive upscales at 4K, I'm seeing the overall geo mean at 23% faster. This is grouped by game. We could see this instead sorted from best to worst. And again, what you're seeing here isn't frame rates, it's the percentage advantage for the 5090 versus the 4090 per game and setting. Again, the biggest outlier is the 42% faster on native 4K RT Overdrive, which for one thing just isn't the way you would play the game. And I already mentioned earlier in the video, I think it had to do with rounding errors, where if there had been some rounding up and rounding down, you can easily get 42% from low numbers versus 33 versus 25 being 32%. So I think that's really just a rounding error thing happening there. Where it's making it look like a bigger difference than it really was when expressed as a percentage. Now, if you're wanting to break this down a little bit more, we could look at just 4K native. Actually, this will be 4K, all my 4K results. This is 4K results, but there is including upscaling. So with that in mind, we're now seeing 25% advantage for the 5090 versus the 4090. And if I only include native 4K results, which probably isn't necessarily the way you would play, I would honestly probably use DLSS quality even on a 5090 if I have a high refresh rate 4K display. Here we're seeing 26% faster. So the less likely you are to be at all CPU limited, the more closer to a 30% performance advantage we start to see. Also, we could look at strictly 1440p results, where you see, again, an indication that these are being held back a little bit by the fastest gaming CPU on the planet right now, the 9800X3D. So the 5090 is only showing as 21% faster if we limit it to 1440p results. If we just limit to ray tracing results, we see an overall 26% performance advantage here. Again, probably less likely to be CPU limited here with the additional burden on the GPU, although ray tracing does also put a burden on the CPU. Anyway, so that's the overall results. Like I mentioned earlier in the video, this is up against a non-Founders Edition 4090. So if you see a few differences in the percentages, like if somebody else saw 30% faster, it's probably, related to what games you test, because we can see that those vary, as well as which model of 4090 and 5090 you're putting head to head. But again, that doesn't make a massive difference. We're kind of seeing this. Now again, Nvidia's big claim is the DLSS 4 multi-frame generation. I'm going to have a separate video with more of my thoughts, and I've already covered a lot of them here, but if you're skipping to the summary at the end, I think this is a really useful feature for 200 plus hertz displays, because it allows you to take a 60 FPS rendering frame rate, which feels pretty responsive, and then take advantage of the high refresh rate hertz on your monitor for motion fluidity. It's not going to increase the responsiveness, but it does generally make a better experience in the games I've had time to test with so far. So I do overall like multi-frame generation, but think of it more as a good way to take advantage of the motion fluidity of an extremely high refresh rate display and not as raw performance. It was not a great way to go from 30 FPS to 120 FPS. That's my main thoughts on that. So overall, I think the 5090 would have been more exciting if it was either more raw performance compared to the 4090, or if it cost less than it does at $2,000. The fact that it's basically even price to performance scaling from the previous generation, offering no improvement, is putting a damper on things. But again, we're talking the absolute ultra high end, where I think people are less value conscious. So if the rest of NVIDIA's lineup offers a more exciting improvement in price to performance, in other words, an overall value, I'll be a little more forgiving, but we'll have to see what comes up here. The 5090 itself is an extremely powerful, extremely good GPU that is extremely expensive and isn't a mind-blowing update to the 4090. Anyway, that's where we're at here. If you're interested in I'm on a 3090, should I upgrade to a 5090? I have a dedicated head-to-head video in the works. Stay tuned to the channel. And actually, if you become a channel member, it might even be available when I post this one, but I need to give some separation in my head-to-head videos in the YouTube algorithm. I'll also have a direct head-to-head I'm on a 7900 XTX, but AMD is not making a 5090 competitor. Should I upgrade to a 5090? I've got a direct head-to-head in the works for that as well. And I also will have a head-to-head up against, I think I got a 4080 Super I'm recording this a couple of days before the review embargo, so maybe I'll even fit in some more. I've also got a separate video directly talking about the new multi-frame generation stuff. And also, don't forget to check out jawa.gg and use code OWEN10 for $10 off your first purchase. And thanks again to them for sponsoring today's video. I hope all of you have an excellent day.